to start number 1, I'm going to label the graph. We are talking about temperature over the course of a day. So I'm going to put time on the x-axis with the morning, noon, and night. And that's an M. And on the y-axis, I'll put the temperature in degrees Fahrenheit. So we start at 32 in the morning. So somewhere on this y-axis, I'm going to make sure to label 32, and that's where the temperature starts. It gradually warmed up to 50, so slowly and steadily around noon, it warmed up to 50. So I'm going to label 50 degrees. So nice and gradually. But then it got super cold, and it quickly dropped back to below freezing. 32 degrees Fahrenheit is freezing point, so we're quickly going to drop back down. And that's it. This swimmer has to race to the other side of the pool, so he has a 200-foot long race. He goes 2 feet per second. So at the beginning of the race, before time has started, and we will have the distance to the other side be the y variable. Time is x, distance is y. So before time starts, he has the whole race ahead of him. He still has to swim 200 feet. After 1 second goes by, he's already swam 2 feet. So how many feet left does he have to swim? Since he swam 2 feet, he has 198. How do we get that? Because we subtract 2. Then another second goes by, and he swims 2 more feet, so he only has 196, and then 194. So the y's are going down by 2 every time, and the x's are going up by 1 every time. What do we need that info for? We need it to get the slope. The slope is the change in y over the change in x. So the y's are changing by minusing 2 every time. The x's are going up by 1 every time. So your slope is -2. So for our equation, we have y equals -2x. And the y-intercept is where the swimmer starts. And he has 200 feet to go at the beginning of the race. So let's graph that. We have time on the x-axis, and we can put 1, 2, 3, 4, 5, 6, etc. seconds. We'll put distance remaining, and he has to go 200 feet. Let's see if we go by 10. 10, 20, 30, 40, 50, 60, 70. Nope, that won't work. 20, 20, 40, 60, 80, 100, 20, 40, 60, 80, 100. So let's count by 20s. 20, 40, 60, 80. Then we'd be at 100, 20, 40, 60, 80. Right here would be 200. So at the beginning, we'll plot 0, 200. And then 1 second goes by, and he only has 198. And then another second goes by, he has 196. I know those aren't perfect, but as long as you have a graph that starts at 200 and it goes down by 2 every time, we're good. First, I'm going to look at my y values. I know in piecewise problems, the y's all go in the first column. So I have 400, I have 600, and I have 800. Now I need the interval. All right, the interval for the x's goes in this column. So I'm going to look right here, and I see that this is in between 0 and 4. So I'm going to put a 0, I'm going to put a 4, I'm going to put an x in the middle, and the arrows always point to the left, and I'm going to give them both equal signs because I have 2 dots. If you just put the part that is x is less than or equal to 4, if you just put that part, I would also accept that. Now for the middle one. We have in between 4 and 8. So 4 is the low number, 8 is the high number. X is in between. Signs always point to the left. We leave the first one with no equal sign, and we do put the equal sign on the second one. Last one, this is between 8 and 14. So 8's the low number, 14 is the high number. X goes in the middle. Signs always point to the left. This one does not get an equal sign, but the one by the 14 does. All right, let's see where negative 10 fits for X. All right, if I put a negative 10 right here, is negative 10 less than 0? Yep. So this is the equation we go with, 2x plus 1. But we have to plug the negative 10 in for x. So 2 times negative 10 plus 1. That's going to be negative 20 plus 1, which is negative 19. Next, we're going to see where the 2 fits. Is 2 less than 0? No. Is 2 in between 0 and 5? Yes. So our answer here is 8. There's no x to plug the 2 into, it's just plain 8. Next, we're going to see where 5 fits. Is 5 less than 0? No. Is 5 in between 0 and 5 but less than 5? No. Is 5 greater than or equal to 5? Yes. So we're going to use that equation, x plus 1, but we have to plug the 5 in for x. So 5 plus 1 is 6. To graph the top equation, I know that the first column is the y values. So I'm going to go up 2 on the y-axis, so right here. The slope is 0, it's just plain number 2 on the y. And what I'm going to do is keep the part of the line that is on that side to the left of negative 2. So I'm going to go to negative 2. Here's the cutoff point. You don't have to draw that dotted line, but that's where negative 2 is on the x-axis. And I'm only going to keep the part of the line that's less than that to the left. And I'm going to put an open circle right there. Next, I'm going to go to negative 4 on the y. So it's this entire line down here, but this time we're only going to keep the part to the right of negative 2. And I'm going to have a closed circle. So we keep the part to the right, get rid of the part on the left. Our job here is to add f and g together. So we're going to have 5x squared plus 8x minus 2, and we're going to add to it the negative 2x plus 3. All right, so I drew those parentheses. But does having a plus 1 in front of parentheses really change any of the signs when you distribute it? Not really. So you can just ignore the parentheses if you want to. You're just going to be adding up like terms because none of the signs change in this case. So let's see where all the x squareds are. Looks like there's only 5 of them. Now we're going to put all of the x's together. I have 8 and negative 2. 8 minus 2 is 6. And last, negative 2 plus 3 is plus 1. Notice in number 7, we have to subtract the 2 functions. So it's going to be 8x squared plus 6x minus 2. We have to subtract negative 10x plus 5. Does having a negative sign in front of these parentheses matter? Yes, because it changes those signs. The first function does not change, but what's negative 10? Plus 10. What's negative positive 5? It is minus 5. Now we can combine like terms. We only have 8x squareds. We have 6 and 10 x's, which is 16x. And we have negative 2 minus 5, which is negative 7. Our job in number 8 is to multiply these together. So we have a 3 by 2. You know I'm going to make a box. So here's my 2 by 3 box. 2x squared, 8x, and negative 6 go on top. Negative 5x and 9 go on the side. So now we multiply. Negative 5 times 2 is negative 10. X to the first times x to the second is x to the third. Negative 5 times 8 is negative 40. And x times x is x squared. Negative 5 times negative 6 is positive 30 with an x. 9 times 2 is 18 with an x squared. 9 times 8 is 72 with an x. And 9 times negative 6 is negative 54. So let's combine like terms. We have negative 10x to the third. Negative 40 plus 18 is negative 22x squared. 72 plus 30 is 102. And last we have minus 54. Now we get to divide the functions. So f goes on top. G goes on bottom. And in order to cancel anything out, you have to factor. What's the first step in factoring? Look for a GCF. So let's just look on the top. What can we divide both 2x and 8 by? We can divide them both by 2. What are the leftovers that go next to those? Well, 2 divided by 2 is just 1x, and 8 divided by 2 is plus 4. Now we look for a GCF on the bottom. What can we divide both of these by? 3. So we put the 3, we put our leftovers. 3 divided by 3 is x, and 12 divided by 3 is plus 4. So we do have some common factors on top and bottom, which cancel out. Our answer is 2/3, and we just need to say that x cannot equal negative 4, because if it equaled negative 4, then we'd have a 0 on the bottom. For these composition problems, we work from the inside out. So first I'm going to find f of 3, which means we plug 3 into the f of x function. So it'll be 3 to the third, which is 27. Now we take that 27 and we plug it into the g function. So it means we're going to take a 27 and plug it in right there. So it'll be 2 times 27 plus 9. 2 times 27 is 54, and 54 plus 9 is 63. On number 11, we start off by plugging 2 into the f function. F of 2, it's going to be 2 to the third power. 2 to the third is 8. We take that 8 and we plug it into the g function. So g of 8, it means we're going to plug 8 in right there. So 5 times 8 plus 6. 5 times 8 is 40, and 40 plus 6 is 46. Does this line pass the horizontal line test? No. So the inverse is not a function because it fails the HLT. The first step to find the inverse of a function is to switch the x and the y. So I'm going to write x equals 2y plus 12. Now we solve it for y. So I'll get rid of the 12 by subtracting it. So x minus 12 equals 2y. Now we have to get rid of the 2. And we have to divide both of these by 2. So there's a 1 right there. So our final answer, what y equals, it's going to be 1/2 x, and negative 12 divided by 2 is negative 6. Same first step on number 14. I'm going to flip the x and the y. So x equals 5y minus 30. We need to get the 30 on the other side. So x plus 30 is 5y. Get rid of the 5 by dividing on both sides. And we need to divide the x by 5 as well as the 30. So this simplifies to 1 over 5x. And 30 divided by 5 is 6. For 16, first we're going to take g of x and plug it into f of x. So I'm going to take all of this and plug it in right there. So the function will start off with 1/6, and then I'm going to plug in the 6x minus 24. Then I'm going to keep copying plus 4. So we distribute. 1/6 times 6 is just 1. 1/6 times negative 24, it's basically negative 24 divided by 6, which is negative 4. Don't forget the plus 4. Those cancel out, and we're left with plain x. Now we compose it the other way. Now we are going to write it, I guess I need to see the whole thing, so that we are putting the f of x function into the g of x. So now we're going to take all of this in blue, and we're going to put it right here for x. So the g of x function starts with a 6, and now inside we're going to plug in the stuff in blue parentheses, 1/6 x plus 4. And then we'll finish copying the rest, minus 24. So we'll distribute. 6 times 1/6 is 1. 6 times 4 is 24. Subtract 24. Those cancel out, and we're left with x. So since both equaled plain x, our answer here is yes, the two functions are inverses. And now that I skipped number 15, I'll go back and do it. So we're going to plug g into f first. So all of this is going to be plugged in right here. So I'll start writing the f of x function, 1/7. But I'm going to plug in the 7x minus 42, where the x is. Keep copying the plus 6. We will distribute. 1/7 times 7 is 1. 1/7 times negative 42, just do negative 42 divided by 7. It's negative 6. Those cancel out, and we get x. Now we compose it the other way. So the other way is taking f of x. So we're going to take this one and plug it into g of x. So I'll write the g of x function, 7, but I'm going to plug in the 1/7 x plus 6, and then I'll keep copying minus 42. So we distribute. 1/7 times 7 is 1. 7 times 6 is 42, minus 42. Those cancel out, and we get x. So we got x for both of them. So our final answer here, again, is yes.